So what we've seen so far has been things acting as an acid or base. We get your conjugate acid, things that have an H or gains an H. Now we're going to talk more about when an acid and a base get together. And that's what neutralization is. Neutralization is when you have an acid and a base. Not like a water where it's acting as an acid or base, but an actual acid and a base, and that neutralizes it, okay? An acid getting together with a base. Titration is what we're doing when we neutralize. This is just more or less the process by which you neutralize. So if I've got an acid and a base and I'm pouring together, then I'm titrating. That's the process, and really what I'm doing is I'm neutralizing an acid with a base, or I'm neutralizing a base with an acid. So here's an example. Say we have an acid like HCl, hydrochloric acid, and we have a base. Notice it's with an OH, okay? So this is not going to be just like a donation. This is going to be an actual double replacement reaction, okay? So double replacement reaction, all right? And so you've got your H plus Cl minus. Notice the Na is a plus charge, hydroxide is a 1 minus. The H will get together with the OH, water, HOH, and the Na will get together with the Cl, in this case sodium chloride. But we would consider any of these types of things a salt, okay? So neutralization reaction is when you get an acid with a base. If I were to put another one, let's say we have nitric acid. Well, actually, let me use a sulfuric, let's say. So sulfuric acid, we're going to name these shortly, but sulfuric acid is H2SO4. Let's say I'm getting with sodium hydroxide again. Notice H plus, SO4, 2 minus. That's why you have two H's with the SO4, because you need to balance the charges. And then let's say we have Na with the OH. Notice the H with the OH, and then Na with the SO4. So notice we would still have, I'll grab a darker color, we would still have H2O, that's this first thing right here, H2O, and Na2SO4. Of course, you would need to balance it. That would be balanced, but that's a neutralization reaction. It is a double replacement reaction. So if you get asked a question dealing with titrations or neutralizations, we're going to work on this on a lab, but it is a double replacement reaction. Here's a question. Here's the process. Here's what's going on. Notice that if I'm given an amount and a concentration of one of these, okay, in this case a base, notice this is the NaOH, this is our base part, I may be given the amount of the acid but asked for the concentration. Notice I'm given both the amount and the concentration. The concentration is molarity. Molarity is concentration, moles over liters. Here, notice I'm only given the amount, but I'm asked for the concentration. I could give you the concentration of the second one and ask for the amount, but notice that one I'm giving you both of, one you're given both, one you're not, okay? So here's the idea. If you're given an amount, like 42.5 milliliters, and a concentration of 1, notice I'm solving for the concentration of the other, okay? Here's the idea. I think if you kind of have a roadmap with this, it's a little bit easier. I'm going to give you the idea. We're going to use the fact that we know the molarity formula. Molarity is moles per liter. And so if I have the milliliters, which in essence is the liters, and I have the molarity, I should be able to rewrite this equation for moles, okay? And notice if what I'm asking for, the concentration of the acid, this would be my base, in this case, because I'm given the base, notice that this would be the acid. I want to know the concentration, which is my molarity. That's what I'm really solving for. And notice that I'm given the amount. What I don't have yet is the moles. But if I determine the moles of my base, I can then convert from 1 to the second, because you can convert moles to moles. So the roadmap to how to solve it basically is this. It's two molarity formulas bookending a moles-moles formula, or moles-moles calculation. Okay, so the one that's given, molarity in liters, and then the one you're looking for, bookending around a moles-moles. Okay, so let's take a look. That's the idea. Let's take a look at some more little steps, kind of how I do it. So here's my steps. You got to have the balanced equation, and the reason I say write the balanced equation, you don't necessarily have to do it first, but you do need to have the balanced equation, because to be able to go from moles to moles, you need to use the coefficients of that balanced equation. You're going to solve for the moles of the one you know. You're going to convert moles of A to moles of B. It doesn't have to be the acid to base, but moles of one to moles of the other. And then you solve for your unknown. So, in this case, I have my sodium hydroxide reacting with my acetic acid. This is HC2H3O2. And it's going to double replace. So you're going to get water. Water is always going to be formed in the neutralization reaction. And then NaC2H3O2. Hopefully we see why, because the Na is a plus, OH is a minus, H is a plus, C2H3O2 is a minus, and so we get our double replacement. Okay, I'm going to erase this mess real quick. And this is balanced already. All right, so there's my balanced equation. Now you're going to solve for the moles of the one you know using the fact that molarity is moles per liter. Notice I'm giving you the liters and molarity. So I'm a big fan of rewriting an equation. It's molarity times liter. So molarity is, I'll bring it up here, 1.03 molar times my liters, 0.0425 liters. And I did do this one earlier. What did I get when I multiplied those two together? 0.044. So I get 0.044 moles of NaOH. That's the one that I know. Now I'm going to convert the moles of one to moles of another. So let me bring this down now here. Moles of NaOH. X line. Moles of NaOH. Moles of the other, the acetic acid. Use my coefficients. In this case, it's a 1-to-1. So I get 0.044 moles of my H, C2H3O2. Now I want to know, see here what I get for a color. This green hopefully can work. Yeah, I think we can see that. Now I'm going to solve for my unknown, which is the concentration, which again is, I'm going to bring it up here, moles per liter. So here's my moles, dividing it by 1, 2, 3, 0.050 liters. Hopefully you can see that green. And that will give me my molarity, which is, I'm going to write it, I'll write it right here, 0.08, I think that's right? No, 0.88 molar. That's a big capital M, HC2H3O2. I'm going to put a box around that answer right there. 0.88 molar HC2H3O2. That's a neutralization reaction problem.